Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Okay, now children, today we are going to learn the topic of compression. And before I actually discuss it myself, may I get some idea from your end? What do you think is compression? Is any idea about the term? To compress, compression. Okay, fine. That's great, wonderful. Let's see what the actual discussion or definition of data compression is. And why do we need this to happen? If there are some situations where we need to reduce or compress the size of the file, and the reasons are, the first and foremost is we need to save storage space. Like I don't want to consume a lot of my hard drive capacity or my SSD capacity. And in that case, I'll be going for compressing the file. I'll be going for reducing the size of the file. Secondly, I need to compress so that it is going to take lesser time to stream a music or a video file. Like for example, talking about you are watching some video or some listening to some music. So if the file is in compressed form, it will be faster to you can say stream that file in case if it is in the compressed form as compared to if it's in the uncompressed form. Thirdly, we need to talk about the reduction in the time taken to upload or download the file or even transfer the file across the network. If, for example, I want to move the file from one place to another, or I want to upload or download a file, in case of compressed versions, it is going to be taking lesser time as compared to the uncompressed version. Okay, now one more term that I need to know regarding this transfer of files is the term bandwidth. And what is bandwidth? We hear this term quite often that my network bandwidth is this and that. So this is the term that we need to know. It is the maximum rate of transfer of data across the network, and it is measured in bits per second. How many bits per second are transmitted over your network? And if there are more bits per second, it means your bandwidth is better as compared to if it's a lesser bandwidth. And for example, if you're downloading some file from the internet and basically the web server, then this is something that is quite much popular, quite much in use, that we talk about the term bandwidth, that how many bits are needed or how many bits per second are needed to transfer the data from one end to the other. Now, one thing that we need to know is that the compressed files are going to contain lesser data as compared to the original ones. The uncompressed ones are going to have more data. The capacities are going to be more as compared to the compressed versions, which are going to be faster, which are going to be transmitted faster, which are going to consume lesser space, but definitely the quality is not going to be the same as the original files are. And this is what we need to remember, no matter whether your what your main objective is. Do you want to work on compressed form, which is going to be lesser quality, or you want to you don't want to compromise on the quality, you want the quality to be the best, then you will go for uncompressed files. Definitely, when you have reduced file sizes, that means reduced costs also, because it will be consuming lesser space on the hard drive. So it means that you will not be needing bigger hard drives because it will be consuming lesser space on the hard drives. Is this clear? Now the question comes in the paper regarding the data compression. Why do we need to compress the data? Write the points, write two key features. I think you can simply very easily remember and write down the first 2 points. And in this manner, you'll be able to easily score 2 out of 2 just by writing down the storage space on the devices, or the time to reduce the time taken to stream a video or a music file. Now, since you've understood what compression is, the next one is types of data compression. But by the way, before I move on to this one, do we actually know the software, the names of any program that is actually meant to compress the files? Okay, that's great. WinRAR and WinZip. But the most popular one nowadays is WinRAR. I hope that we all have experienced in order to decompress. We must have seen that we are always asked to decompress by using this. So this is the basic thing that we need to know. What are the 2 types? The first one is lossy file compression. And what is it? This term is new. We have never heard this term. And in this, what happens is the file compression algorithm is going to eliminate unnecessary data. What is unnecessary? In reality, nothing is unnecessary. But in this case, we will learn what is unnecessary, which can be removed, and still the human is not going to notice that change. And definitely, again, I'm repeating, if my concern is the quality, I'll never go for compression. Or maybe if I'm going to for compression, that will be the other format. But if quality is not my major concern, I can compromise on the quality, then I'll be going for lossy compression. So in this case, there will be some loss of data, but what that loss will be is going to be discussed just now. But one thing that we need to remember is once the lossy file compression algorithm is applied on the file, we can never get the same data back. The data is lost forever. You cannot recover the data. The file cannot be reconstructed because it has undergone lossy compression. You cannot get the same file back. It's gone. Fine. On the contrary, the next one is lossless file compression, and as the name implies, there is no loss of data. How does it do? All the data from the original file will be reconstructed. Like if you have original file where that was containing some data, so definitely when you talk about the lossless compression, that will be able to get exactly the same file back without any loss of data at all. Still, compression will be there, but it is only used in some scenarios where loss of data is disastrous. For example, think of this scenario, like for example, I'm your teacher and I have taken your test and I want to send your results, your test results to your class teacher. I'll be sending your results in a spreadsheet file. What do you think? Is it making any sense that the spreadsheet file has containing lesser data? I mean, is it possible I have, for example, 50 students? So when the file will be received on the receiver's end, the number of records and the number of values should be exactly 50, isn't it? There should be no loss of data. That is what is going to be lossless compression. Same case goes for word processor files. And again, I'm repeating, just be cautious that whenever we talk about software, we never ever use the brand names. We're not allowed to use the brand name. The examiner says that you are not allowed to use. So please remember this, that brand names are not allowed. So if a word processor file, maybe I've written some essays. So again, the same should be applicable, that the data should be exactly same as it was on the sender's end. Otherwise, it will be a disaster. Similarly, I have saved some database files. The same lossless compression should be applied there because again, in the databases also, loss of data is disastrous. Any other thing that comes to mind. For example, if I've prepared a Python program or I've prepared a program using any programming language, what do you think? Should it be undergoing lossless compression or lossy compression? And why? I not only want the answer of the type, I also want the reason that why do you think that compression that you are mentioning is the right choice? Come on, be quick. I want the answers, please. Programming source code should undergo lossless compression. Correct. Very nice. And the reason is, okay, that's correct. The reason is definitely very clear that if I talk about lossy compression being applied on the program, it means that the program will not be same as I wrote it. There will be some changes, and those changes will definitely be not doing the work as I desired. And that is why those files should be undergoing lossless compression, whether it's a word processor file, whether it's a spreadsheet file, whether it's a database file, or even if it's a program file, a source code that I have typed, that these all should undergo lossless compression. The original file should be reconstructed, should be received once it has undergone the compression on the sender's end, and it is going to be decompressed, uncompressed on the receiver's end. Now, lossy file compression, we're going to discuss a little bit in detail that which file formats are actually the lossy file formats. The common lossy algorithms are, the first one is MP3, and I hope that we all are okay with the term MP3. We hear this time quite often, or MP4. And secondly, JPEG or JPEG. Some people call it JPEG. And by the way, you can see that we rarely come across expanded forms. but the expanded forms are also mentioned here for your own learning. That MP3 stands for motion, actually the full name is MPEG, and it is Motion Pictures Expert Group. And JPEG or JPEG, which sometimes the people call, is Joint Photographic Experts Group. So these two, or you can say three file formats are basically the lossy file formats. It means that the original file can never ever be reconstructed once it has undergone the lossy file compression. What is done and how is it being done? Now the question arises. First thing is, what is MP3? MP3s are basically used for playing music on computers or mobile phones. Like for example, nowadays, whichever song or not or whatever you want to download, you may have seen that they are always mentioning this as an MP3 format. And this compression technology is going to reduce the size of a normal file, music file, by about 90%. Imagine such a great reduction. Like, for example, it's just an example. If, for example, the original file that I had was of 80 MB, and after it has undergone compression, which is the lossy compression, so the music file will be no more 80 MB in size. It will be reduced to only 8 MB because it is left with only 10% and 90% is gone. So if you just simply apply 80 MB into 90%, you will get the value, or you can say 80 MB into 10%, which is the remainder. So you will come to know that it will be only 8 MB in size, and that is a great reduction. See, such a great reduction of your storage media. And definitely mobile phones are benefiting a lot because of these MP3 formats. Now, how is it being done? Again, one thing, they are not going to be exactly matching the quality of the originals, but this is satisfactory. Like for example, it's okay for me if I am downloading an MP3 file from MP3 file that and I may not be able to notice very great difference in the quality of those sounds and how it works. Let's see, that really very interesting. First thing is, how is it being done is there are some sounds which human ear cannot hear, which are outside the human ear's range. So those sounds are eliminated. Those sounds are removed. Secondly, if two sounds are played together, then the louder sound is kept and the lower sound is eliminated. Like it happens with us too. If, for example, I'm standing in the class and you all are speaking, so definitely what happens, if the class of 25 or even 30 students is there, and they all are speaking together at the top of their voices, and I'm also there. So definitely, which sound will be more audible in your ears, mine or your friends or your classmates? It's definitely your classmates because the classmates are speaking so loudly. So same case goes in my voice may not be heard by some students, and the same is happening here. First thing is the sounds which are outside the human ear range, they are eliminated. And secondly, if two sounds are played together, then the louder ones are kept and the lower sounds are eliminated. And the process is called perceptual music shaping. Please remember this process, the process in which the louder sounds are kept and the lower sounds are eliminated from the file. This is given the concept of perceptual music shaping. I hope that these two are clear. Any questions regarding this before I proceed to the MP4? I mean, like you must be knowing, most of you are aware of the term MP4. And the MP4 formats are basically the storage of multimedia files. And when you talk about multimedia, it's not only sound, it deals with videos, photographs, animations, everything is included in the MP4. So are we all clear about the lossy file compression, that is MP3 or MP4? Before I proceed to the JPEG. Okay, that's great. The next one is JPEG, and what is it actually? If I take a picture using the camera, definitely the picture is going to be a raw bitmap image. It will be, the size of that file will be too high. The size will be too large. On the contrary, I want it to be reduced. So what happens is I'll be applying a lossy file format file compression algorithm. And with application of that algorithm, what happens is the original bitmap images, which were occupying a large storage in the storage media, they'll be reduced tremendously. And the original, and once again, the original file cannot be brought back. Please, I keep on repeating, Lossy means the original files are lost. You cannot get the same file back. It is gone. Just like, for example, if I say burning of paper, if I say burning of paper, that is actually lossy. I cannot reconstruct the paper back. The paper is burnt, the paper is gone, and I can't get it back. Same case goes with your lossy file compression algorithms. Once they are applied, then you cannot get the same things back. They are gone forever. Now, what happens in JPEG? How does it take place? Again, the same, something similar to the same as we talked about regarding the MP3. Same case goes here. The human eye Allah Ta'ala has made this, that the human eye cannot detect the differences in the color shades. So that is going to be the main thing that will be worked upon, so that the human eye cannot see the differences, cannot observe the differences, so they are removed. For example, another thing is by separating pixel color from brightness, and images are split into 8 by 8 pixel blocks. And in this manner, some information will be discarded, and this discarding of information will bring some difference in the storage, but may not bring a lot of difference in the quality. So since quality is something that, like again just like in MP3, the quality of the picture may not be observed by the naked eye. So that is how the JPEG file formats are also undergoing using the lossy algorithm, lossy algorithm. They're undergoing the process in which the original file is going to be reduced in size. We cannot get the same file back. And it is working on some principles of the human eye that it cannot detect the difference in certain quality. Any questions before we proceed to the lossless? Any questions? Is it clear? Is it understood? Lossy means loss of data. MP3, MP4, and JPEG are undergoing lossy compression. Now, if I move on to lossless, the algorithm that is applied is RLE, run length encoding. So we are just learning that how it takes place. First thing is that we all need to know is run length encoding, or RLE, is one example, one form of lossless or reversible file compression. Reversible means I can get the original file back. Whatever was there, I can get the same file back. How is it being done? It reduces the size of a string of adjacent identical data. Now, how it works is, we'll be working on some exercises, but before that, we need to know that it's going to reduce the size of a string of adjacent identical data. If the data is adjacent, if the data is identical, that data will be eliminated. That data will be stored in a different style, eliminated in the sense that it will not be exactly same as was in the original one. So there will be some change in the storage of that data, and this is how it will result in reduction of the file size. And how is it being done? A repeating string is encoded in two values. What is being done? The first value is indicating the number of times that the letter is occurring. For example, maybe if the letter A is occurring 10 times, so it will store that the first value is going to indicate the number of times. For example, 10 times the data is occurring, and another value will be indicating the ASCII code. By the way, ASCII code is something that you are aware of a little bit, but we will talk about this also. ASCII code is actually a type of your code that is representing the keyboard character. So one thing that will be it will be encoded in your RLE is, now moving back to the same, we have to remember the first thing is going to be the value that is going to represent the number of times that string is occurring, and second will be the ASCII value of that particular character. It's very effective. It's going to be, actually, you can see the effectiveness of this algorithm or this technique. If case you have a long string of repeated units or repeated bits. If it's a smaller value, then you may not see much I can say much difference. But if it's a long value, if it's a long file, then you will see yourself that there's major difference. Now we are now learning how is RLE applied on text data. As you can see, the first line is containing 5 times A, then 4 times B, letter B, then 2 times letter C, then 5 times letter D. So this is my original file. For example, if I'm sending that one string of data containing 5 times A, 4 times B, so 2 times twice C, and the letter D is occurring 5 times. So that is going to occupy 16 characters. And remember, each character will occupy 1 byte. It means that there will be 16 bytes occupied for storing of this string. On the contrary, if I talk about the compression, the RLE compression algorithm being applied, what will happen is, now instead of sending that 5 times A, it will be only sending 597. And what is 97? I mean, although I told you not to learn, but still some of you can recall that 97 is the ASCII code of letter A, small a. By the way, what is the ASCII code of capital A? If anyone can recall. That's great. The ASCII code of capital A is 65. By the way, are ASCII codes one after the other? Or, like for example, if I say small a and small b, are they, is it easy to remember? That's wonderful. You can see yourself that just after that letter A, it's letter B, which is occurring 4 times. So it shows 4 times 98. So the ASCII code of small b is 98. That's why it is going to indicate 4 times 98. Then twice 99, that is going to be 2 times 99, which is C. And then 5 times 100 because of D having the ASCII value of 100. So in this manner, the original, the one uncompressed file, if it was containing 16 characters, occupying 16 bytes. Now in the compressed file, you can see it is now going to occupy only 8 bytes. And because each value will be stored in 1 byte, it means total 8 bytes will be consumed, will be sent, and that means nearly 50% of reduction. It means that the original file, if it's 16 bytes, the compressed file will be 8 bytes, half of the original file. Although the string is not very big, still you can see 50% reduction. So if the string is big, definitely you can assume yourself that how much the data will be in the compressed form. Any questions? Is it clear? Now, if I ask you, this is also text and that was also text, what is the difference that you can observe in the two text values? They both are text data. The first one was also text data and this one is also text data. Giving you 1 minute to observe and let me know. Are they exactly same? Oh, no, they aren't. Fine, that's good. They aren't, but what is the difference between the two? Okay, that's great. You can see a little bit of it. You are on the right path. The first example that we talked about was containing only the repeated characters. But here you can see which characters, by the way, are repeated and which are non-repeating. The letter A is repeated 8 times, correct? The letter B is repeated 10 times, correct? But if you see CD, it's not C together. It's C, after that it's D, then CD, then CD. So that is, again, you can see in between there's some values which are non-repeating. And in the end, we have E again repeated 8 times. So this string is containing a combination of repeating and non-repeating characters. So how will we handle this? Let's see. If I talk about the original, that is going to be of 32 bytes because it's of 32 characters. So if I talk about the compressed one, there's a little change. In this case, the change is it will be the introduction of a flag. And what is this flag actually? The way if you talk about the term flag, it indicates, what does flag indicate in real life? Like flag of Pakistan, flag of our country, flag of our school group, flag of our, can say whichever house you are in. So these are all flags. So here the flag is 255. And what is happening here? You can see it says not only 897, but it also says 255. By the way, how many times is this 255 occurring in your compressed file? Quickly observe and let me know. Is it occurring once or twice or thrice or 4 times or how many times? That's great, wonderful. You can see that the flag value of 255 is occurring once with 97, second time with 98, and third time with 101 only. It means that this indicates that 255 is the flag value for indicating 8 times 97, or A is there. 255 flag value indicates that 10 times 98 is occurring repeatedly. And then 9900 indicates it's not, although 99 after 9900 is there, but that is a non-repeating character. 9900, 9900, 9900. And after that, 255 is occurring once again, and again you can see 8 times 101, which is the letter E. So in this manner, introducing a flag value is going to make your life a little easy. I mean, again, not my life. It's basically the algorithm that is doing the task for me, that it is going to reduce the file size definitely. And how much? Let's see. After the compression is being applied, it will be occupying only 18 values. And definitely that means it is going to reduce by a certain value, by a certain percentage. Reduction in file size is about 53%. Now, original was 32 characters, and after compression has been applied is 18 values, and that is going to be a certain reduction in your file size. Clear? Any questions regarding the applying RLE on text data? Before I proceed to RLE on images, I mean, this is something which is really interesting. Up till now, we have been talking about images which have to undergo compression, and that is lossy compression. But let's see how is it done and why is it done. Once you are able to see that figure, you will be able to comprehend this very easily, but how is it being applied. Now, you can see here, we have a figure that contains the letter F, and this is the letter that is in a black and white format. So here you can see the letter F in the grid is actually, how many squares are there? 1, 2, 3, 4, 5, 6, 7, 8 squares. 8 squares horizontally, and how many squares vertically? 1, 2, 3, 4, 5, 6, 7, 8 squares vertically. It means total 8 squares horizontally and total 8 squares vertically. And what is happening here is, rather than storing the, like this is one thing, like you can see the letter F is there, and the letter F is shown by a black color, and whatever is not occupied is shown by a white color. Perfect. The same thing is shown by a combination of ones and zeros in the next figure. As you can see, all whites are represented as ones, and all zeros are representing the black color. So you can see a combination of ones and zeros in your figure. I mean, which is not very easily understandable to many of you, but it is actually simply representing the white for a white with a 1 and black with a 0. And if I talk about the 1, if I applied compression, now what you can see here is the first line contains 8 whites, but on the next line is the 9th white also. So that is where you can see in the compressed RLE format, it becomes 9 whites because of consecutively 8 times white is there. Any questions? So you can see the figure F is containing, in the first line, or in the first, you can say row, there are 8 consecutive white characters, and line number 2 also contains a white character. So a white box or a white pixel. So, or a white, you can say box. So what is going to happen here is we can store it as 9 whites or as 9 ones. If I say 9 ones, 9 whites means it's going to be represented by a 1. So instead of writing 9W, I can say 9-1 also. That means the same. Now moving further, we have the black, which we can see the first line, which is containing 1, 2, 3, 4, 5, 6 blacks. So either you say 6 black or you say 6-0. They both mean the same. Fine. Then again, after that, you can see in the second line, the last box is a white, and on line number 3, again, there's another white. So can I merge the 2 whites together and can say it's 2 white? I hope that there's no harm. Remembering that my file header contains the information that it's in 8 by 8 square. So definitely I know that it's continuity, already we are done with the one white and then 6 black. So it means that if it's the next one will be 1 white, and next value is going to be taken from the next line. It is not going to be the 9th square on the picture. It's impossible basically. So if I just say after 1, it's going to be the next line, third lines, white also included, that makes 2 whites. And then how many blacks? 1, 2, 6, 5. How many blacks in the third line? 1 black only, correct. As you can see, 9 whites, 6 black, 2 whites, and then 1 black. After that, how many whites can you see? This line, the third line, contains 6 whites, but the fourth line also contains a white. So can I merge the 2 lines together in this manner only, that I can say 6 whites plus 1 white makes 7 whites. So it makes the concept a little clearer. Fine. The fourth line contains 1 black. As you can see, 1 black. And then it's again going to be 6 whites and then 7th white from the next line. So that makes 7 whites. And then we have 1, 2, 3, 4, 5 blacks, that is represented as 5B or 50. And then it is going to be 1, 2, 3. The third box of white is from next line. That makes it to be after 5 black, it's 3 whites. And then goes on from in the fifth line, it is going to be 1 white, then 1 black. And then you can see 1, 2, 3, 4, 5, 6. And then 7th white is again from the 7th line. And then it's 1 black. And then again 6 whites. And then 7th white is from the next line. So you can see 7 whites and then 1 black again. And then in the end, we have 6 whites. So in this manner, we can see the whole picture has been compressed. And if we talk about the original is occupying how much space, definitely there will be reduction in the file. And most important thing is this file, after being reduced and then uncompressed on the receiver's end, will be brought back to the original form. You can see the 8x8 grid, or I can say 8x8 squares picture is going to be definitely simply 64 bytes, because each square or each value is going to be occupying 1 byte. But on the contrary, if I count the total values in my compressed algorithm, after compression algorithm is applied, is of 30 values or 30 bytes only. And that is again from 64, it is 30 bytes only. And the best thing is you will be able to get the original file back. There will be no loss of quality. This is a reversible compression where you can get the same file back. Is it clear? Now, please remember, JPEG is a lossy file format, while RLE is a lossless or reversible compression algorithm. Any questions? Okay. Now, the last thing that we are learning is how is RLE applied on colored images. Color, that's great. Let's see. Now, you can see one thing that we have studied at different time intervals, which we all need to know, is the color is made up of basically 3 main colors, which are RGB, which are called RGB or red, green, blue. And how are they being coded? That's really an interesting thing. Very first thing that you need to see here is this is the picture. And this picture is containing 1, 2, 3, 4, 5, 6, 7, 8 squares horizontally. And if I count vertically, it is 1, 2, 3, 4, 5, 6, 7, 8 squares vertically. It's also 8x8 square, but the difference is this 8x8 square is composed of colored images. It's not black and white, it's a colored image. Apart from this picture, by the way, again, a little bit of the discussion. The first line is 2 blacks, then 6 green, then 2 black. And then next line contains another black. So I can say, if I'm going in a sequence, I can say 3 blacks. And then it is going to be 6 times the white is there. And then a black, 1 black only. So again, just remember the sequence. And then we can see a green, 2 greens are there. Then 4 blacks are there. Then 2 greens. And the next line contains 2 greens. So I can merge and I can say 4 greens are there. I hope that there's no problem in understanding. The only change in this one is earlier picture had only black and white image. Now it's a colored image. And this color is shown by a combination. As you can see, it's showing, like for example, if I say black color means absence of colors. And that is represented by no red, no green, no blue. All the 3 components are 0. As you can see, the black color is red 0, green component 0, blue component 0. On the contrary, if I say white, that means every single value, like red is 255, green is 255, and blue is also 255. If I say green color, that means red is 0, green is 255, and blue is also 0. And the last one, red color, it means it is red 255, 0 for green, and 0 for white. So this is just something, again, you don't have to please rote learn these values at all. If you are getting a question, you will be always told that how to represent a black or white in a black and white color, or if it's a colored image, how will it be represented? Please, please, please do not ever think of rote learning this stuff. Now moving to the compressed form, as you can see, the picture contains two black. And since the black color is represented as 0, 0, 0, that's why you can see in the first one, it says 2 times the black color or 0, 0, 0. Any questions? 2 times 0, 0, 0. Then after that, it's 4 green. So the color for green is 0 to 55, 0. So that is what will be 4, 0 to 55, 0. 4 is indicating the number of times, the number of occurrences, and 0 to 55, 0 or any other value is taken from the table, and you're only going to put the value from the table. And the value for green is 0 to 55, 0. That's why it is going to be 0 to 55, 0. Fine, any questions? Okay, now let's move. And then we have black. 1, 2 in the first line and another black in the second line. So we have merged the two lines together, and we have got 3 blacks. And since the black color is 0, 0, 0, that's why you can see 3 times 0, 0, 0 is occurring. Fine. Then there are 6 whites, as you can see, 6 times white. And the color for white is 255, 255, 255. That's why you can see 6 times 255, 255, 255 is there. And then after that, it's 1 black, which means 1. And the color code for black is 0, 0, 0. So 0, 0, 0 will be there. I hope that we can do the rest very quickly. We are done with 2 lines, and then you can do the rest. The third line is starting with green. Twice it's green. So we have, we can see it's 2. And since the code for green is 0 to 55, 0, that is why you can see 2, 0 to 55, 0. That is indicating twice the green color is there. I hope that is very much clear. I'm giving you 3 minutes to complete this, and you can verify your answers from here. That is your answer matching with what is written on the screen. Any questions? After this green is 4 times red color, correct? 4 times the color red means 4 to 55, 0, 0. Have you all got the answer correct? You can see the original one was 8 by 8 square, and since each square was occupying 3 bytes, so you can see for yourself the total occupation of the total bytes occupied will be 8 into 8 into 3, and that is 192 bytes. So it means that this picture will be occupying 192 bytes. On the contrary, if I talk about the reduction, RLE, it will be 92 values, means 92 bytes only, and that is again nearly 52%. So I hope that this is very much clear to all of us. We all are able to comprehend this topic very easily, very well. No questions, no problems regarding this topic at all. Any questions regarding this topic before we move on to any other thing? No questions? Okay, that's great. So what we have, let's very quickly recap what we have learned right now. First, we talked about the term compression. What is compression? Then we talked about the types of compression, which is lossless and lossy. Then we talked about the uh, lossy. What is it? For example, MP3, MP4 is lossy. We talked about JPEG, which is lossy. How is it being done? Why is it, how is it being done? So I hope that it's very much clear to all of us. Then we talked about the lossless. What is lossless? In which scenarios is lossless feasible? Then we learned that how is RLE applied, which is a lossless file format on images, colored images, and the black and white images, and the string of data also. So is this whole topic clear to all of us? Jazakallah khairan kaseera. Allah Hafiz. If you have liked my video, please subscribe to my channel and share with your friends and family. And keep on watching my videos. The next video will be inshallah dealing with the addition of binary and other stuff. So please keep on watching. Allah Hafiz once again.